Alrighty guys, in 11-4, we're going to be talking about standard deviation. So the definition of standard deviation is the most useful measurement of spread when data is normally distributed. So this only works when you have that perfectly symmetrical data across where your data is spread. So it's a measure that shows how data varies or deviates from the mean. So when you're looking at a normal curve or a normal bell curve, like what is pictured below, your mean is always this number that's in the center. So this one right here, I know it's a weird looking symbol. This is always going to be your mean. And then from that, there are these standard deviations. That's what these symbols mean. Standard deviation. And basically, it's telling you, so within one standard deviation to the right, so that would be the positive, and one standard deviation to the left, which would be the negative. So if you add, they'll tell you in a problem, your mean is this and your standard deviation is this. So from that number of your mean, you're going to add to the right, and you're going to subtract that number to the left. And within that first one to the right and one to the left, that's where 68% of your data is at. So that's a very big chunk of your data. Or one to the right is 34 and one to the left is also 34%. So it's very, very symmetrical and even of how this is laid out. And we're going to make one of these on our own, and it probably will make a little bit more sense when we do it. And I'll explain this again. So then again, if you add twice to the right, so 1, 2 to the right, that is another 13.5% of your data. And if you add another one to the left, that's another 13.5% of your data. So within these 4 sections, that's where 95% of your data is held. And then if you keep going, if you add another one, you get to 3 standard deviations away, which adds 2.35% on both sides, which then if you add all 1, 2, 3, 4, 5, 6 of those columns up, you get 99.7% of your data. And then you can keep going to that 0.15%, which would be 4 standard deviations away. But that one, and we can keep going. If you add all this up, all of those percents should add to 100%. So looking below, it says data values that are more than 2 standard deviations away from the mean are considered unusual. So most of your data that is useful and very relevant to what's happening is going to be within that 95%. So those are your usual data. And then the ones that are kind of further away from what's happening are outside of those 2 standard deviations. So let's try a problem together. And I know this may be confusing, but let's try one together. So this first problem says, for the given data set, which values would be considered unusual if the mean is 72 and the standard deviation is 8. So let's draw our bell curve. And I know it may be a little hard to draw, but do your best. Mine's not perfect either. I'm going to try again. So we have this bell curve. Maybe I should make it higher. Okay, so we have this bell curve, and we need to kind of fill in our numbers. So remember, we talked about that our mean is always in the middle, and they just told us that our mean is 72. And then they told us that our standard deviation is 8. So what you're going to do is you're going to take that 8 and you are going to add 8 to the right. And you're going to do that 3 times. So let's add 8, so that's 80. Add 8 again, that's going to be 88. And add 8 one more time, and that's going to give us 96. So what's happening is right here, and this is always going to be the same percent, just like on that last one we had. This is 34% of our data. This is 13.5% of our data. This is 2.35% of our data. And this is 0.15% of our data. So we're going to do that the same way going to the left. But this time when we go to the left, we're going to subtract 8. So 3 times, we're going to subtract 8 to get these numbers to the left. So 72 minus 8 is going to give us 64. 64 minus 8 is going to give us 56. And 56 minus 8 is going to give us 48. So again, these percents mirror each other. So the middle 2 columns are 34%. The next 2 columns are both 13.5% of our data. The next one is 2.35%. And then that last little one is 0.15%. So this is how your bell curve is always going to look. The only thing that's going to change is your mean and your standard deviation each time. So they told us that when we're looking in our data, the middle 4 columns, or 2 standard deviations away, 2 to the right and 2 to the left. So 2 to the right would be these 2. And 2 to the left would be these 2. So this is where your usual data is at, which means that the ones outside of here, the red, let me do the highlighter. The red ones out here is where your unusual data, so unusual data is outside of those 2 standard deviations away. I can't spell. Okay, so they asked us if we look at these numbers above, which ones are unusual. So that means any numbers above 88 or lower than 56 are going to be unusual. So that looks like 53 would be considered unusual. 68 falls in that usual range, so does 70, so does 71, so does 72, so does 74. 80 is good, and 89 is above that 88. So those 2 numbers would be considered unusual. They're far away from our data that's in that really normal range, because remember, this area right here holds 95% of our data. If you add all those percents up, that's where 95% of your data is. So most of your data is in that area. Okay, let's look at another example together. So it says 57 cars had their speeds measured as they drove down a particular street that had a speed limit of 60 miles per hour. The data was found to be approximately normal with a mean of 56 miles per hour. Sorry, there's a little typo right there. And a standard deviation of 2 miles per hour. How many motorists were driving at a speed between 54 and 58? So first, we need to draw our bell curve. And we're always going to get our bell curve from our mean and our standard deviation. So those 2 things are super important. So draw your bell curve. And our mean is always going to go in the center. So 56 was our mean. And from there, we're going to use our standard deviation. So to the right, we're going to add our standard deviation 3 times. So our standard deviation was 2. So we're going to add 2 3 times. So 56 plus 2 is 58. 58 plus 2 is 60. 60 plus 2 is 62. So then to the left, we're going to subtract 2 3 times. So 56 minus 2 would be 54. 54 minus 2 would be 52. 52 minus 2 is 50. Now, within those middle two columns, that's 34% of our data. Both of those are the same. Then our next percent is always 13.5%. Then our next two columns are 2.35%. And then our last ones are always 0.15%. So they asked us to tell them what percent of drivers were driving between 54, and 54 was right here, to 58. So they want who was driving between those two speeds. So if I add 34% plus 34%, I would get 68%. So 68% of drivers were driving between 54 to 58 miles per hour.